Welcome back to Topic 10 for Algebra 1, Solving and Graphing Absolute Value Inequalities. In Part 2, we're going to build on what we learned in Part 1 and solving complex absolute value inequalities. In our example here, we have, if I can get it, nope, okay, there we go. In our example here, we have negative 2 times the absolute value of 4 plus x is less than or equal to negative 4. Now, the first thing that we notice is we want to isolate our absolute value. But instead, we have this straggler here. We have this negative 2 that's being multiplied on the outside of it on that left-hand side. So we need to undo it and remove it. Now, oftentimes what students would want to do is they'd want to distribute this negative 2 in. However, that can actually change the value of this inequality, which we don't want to do. Because remember, absolute values always make everything positive when it spits it out. And we have this negative 2. So we don't want to change its actual value. Instead, we notice that this is multiplication, negative 2 times the absolute value of 4 plus x. So we want to undo it with the inverse, which is division. We're going to divide both sides by negative 2. Negative 2 divided by negative 2 reduces to 1, and we're left with the absolute value of 4 plus x is less than or equal to negative 4 divided by negative 2, which gives us positive 2. However, notice here I divided by a negative number. And if we remember back to topic 7, when you divide by a negative number, what happens to our inequality? It flips. So instead of less than or equal to, this is going to change to greater than or equal to because we divided by a negative number. And remember, this can happen when you multiply by a negative number or when you divide by a negative number. Now we're left with the absolute value of 4 plus x is greater than or equal to 2. Once we're at this point, we've already isolated our absolute value. We can do two things now. We can decide where we're going to shade on our graph eventually, and we can also split. So if we look at our inequality right here, we have greater than or equal to, greater or. So this is going to tell us that we're going to have an or compound inequality, and we're going to shade two tails. Now notice how when we originally started the problem, we had a less than or equal to, also known as an and compound inequality. But our absolute value wasn't isolated. We had that negative 2 straggler hanging on in the front. So we need to make sure we isolate that absolute value first in order to determine where we actually need to shade. Now if we're going to rewrite and split our absolute value inequality, we will get 4 plus x is greater than or equal to positive 2. Remember, we're going to keep it, copy and paste, just drop that absolute value. And 4 plus x is less than or equal to negative 2. So remember, this time we have to change the sign, the inequality sign, and the sign of our number. Now, since this is a positive 4, in order to isolate x now and solve for x, we're going to apply the inverse, which is negative 4, subtract 4. And I'm going to do the same thing to both inequalities, just to speed up the process. So we get x on the left-hand side is greater than or equal to 2 minus 4, which is negative 2, and x is less than or equal to negative 2 minus 4, which is negative 6. So remember, this is an or compound inequality. So our answer is x is greater than or equal to negative 2, or x is less than or equal to negative 6. We can plot this on our graph here. So we have we have negative 6, negative 2. Because this is or equal to, it has that horizontal bar underneath, we're going to have a closed circle. And we're going to shade two tails as we already identified, so in opposite directions. And there we go. Moving on to our final example. Here we have 9 times the absolute value of 2x plus 3 minus 4 is less than or equal to 5. Now with this problem, what I want you to first think about is treat it as 9y minus 4 is less than or equal to 5. How would we solve this inequality? Now I'm going to do this on the side here, and we're going to reference it later on. First, what you would do is you would get rid of that third wheel, that negative 4, by adding 4 to both sides. So we have 9y is less than or equal to 5 plus 4, which is 9. Then, since we want to isolate that y, we're going to divide both sides by 9 because it's 9 times y. So we undo with the inverse, and we get y is less than or equal to 1. Now exactly what I did down here in this process is I isolated my y. Substitute the absolute value of 2x plus 3 in for y. We're going to do the exact same process. We want to isolate the left-hand side so that we can A, split, and B, we can decide where we want to shade. So what we're first going to do, just like we did here, we're going to add 4 to both sides. On the left side, it adds to 0, and we're left with 9 times the absolute value of 2x plus 3 is less than or equal to 9. Then what we did is we divided by 9, so we're going to divide both sides by 9. Again, we don't want to distribute, we just apply the inverse. So this is 9 times the absolute value, so we're going to divide. On the left-hand side, now we have 2x plus 3, the absolute value of 2x plus 3 is less than or equal to 1, which is 9 divided by 9. Finally, we have our absolute value isolated. We can look at our inequality, which is a less than or equal to. Less than is and. So we're going to circle and we're going to ultimately shade in the center. At this point, now we know we can split. So remember, the first one is just copy and paste, but drop those absolute value bars. And our next one is going to be 2x plus 3 is greater than or equal to negative 1. Remember, two things have to change here. My inequality sign and my negative sign. Now this whole problem is basically like a two-step inside of a two-step. We had to add the 4, divide by 9. Now we have 2x plus 3. We're first going to subtract the 3, get rid of that third wheel. On the left side, adds to 0. And we're left with 2x is less than or equal to 1 minus 3 is negative 2. And 2x is greater than or equal to negative 1 minus 3 is negative 4. Now we want to isolate our x, so we're going to divide both sides by positive 2. On the left-hand side, it reduces to 1. So we have x is less than or equal to negative 2 divided by 2 is negative 1. X is greater than or equal to negative 4 divided by 2 is negative 2. We already know that this is an and. So that's our compound inequality right there. Again, we divided by a positive 2. So my inequalities do not need to change at all. They can just stay as is. However, I can actually rewrite my inequalities another way because I'm dealing with an and compound inequality. Remember, and compound inequalities can be written in a smushed way or in like a compact way. So negative 2 is my lower bound, is less than or equal to x, and my upper bound is negative 1. Perfect. So now I can mark those on my graph. Here we have, less than or equal to, so we're going to have a closed circle here, and since it's and, we're going to shade in the center, which we already determined, and there we go. Thank you for watching part 2 of topic 10 for Algebra 1, solving absolute value inequalities.